Hello again, as you know, I'm Eli the Computer Guy, and today's class is Open Compute Project Introduction. So this is one of those things that sounds cooler than it is until you really start to think about what it is, and then it's far cooler than it sounds. It's one of those things that sounds cool, then you learn about it, it looks lame, and then you really start thinking about the overall concepts, the overall dynamics that are going on, and you realize that it's revolutionary. So the Open Compute Project, what is the Open Compute Project? Basically, the Open Compute Project is an open source hardware initiative for data center environments. So normally when we talk about open source, for the last, 15 years, whenever we talk about open source, you think about things like WordPress, you think about software, you think about web apps, that type of thing. Well, within the past, 5 or 6 years, it has become much cooler to start doing open source hardware projects. So basically, with the open source hardware projects, people create the designs, the schematics, all the information in order to build a product, and then they just put it out there on the web for anybody to actually be able to construct it. So essentially, with open source software, what you do is you actually create the software, you create the finished product, and then release that to the world. With open source hardware, what you do is you create the schematics, the designs, the blueprints, and then you release those to the world so that whoever wants to manufacture it can, whether it's a Huawei or a Foxconn, or whether it's some little company out of a 500 square foot room somewhere, deep in the middle of the ghetto somewhere. Basically, anybody is allowed to use those schematics and build the products. So with the Open Compute Project, though, what's very important is that this is a data center initiative. So this came about from Facebook in approximately of April of 2011. Now the reason for this is because data centers have been becoming more and more and more important. So you may think of data centers and you may be thinking, well, Eli, we've had data centers for 2 decades. Really, we've had data centers for 5 decades. But basically, since the internet has existed, since the World Wide Web has existed, we have had data centers. Well, things have changed since we've gotten into the social world. So when we had basic things like websites, we had basic web app databases, that kind of stuff, we needed these data centers. But, we needed them. They were a big thing, but they weren't really that big. It's kind of like one of those things like, yes, we had data centers. Yes, the data centers were very valuable and very important, but they weren't that valuable. They weren't that important. Well, with the explosion of the social networking, data centers have become absolutely huge. I think Facebook now has 14 full-fledged data centers. We're talking about 100,000 servers per data center, and that's Facebook. And then you've got Twitter, and then you've got Google, and you've got Amazon Web Services. Basically, in a very short amount of time, in about the last 5 years, data centers have become a huge, huge, huge thing. Hundreds, millions of servers in these facilities, trying to cool those facilities, trying to power those facilities. In the past 5 years, we have started to run into issues with dealing with data centers that did not exist previously, or when they did exist previously, they could be dealt with. Basically, from a C-level executive's point of view, you could just write a check and pay for it, and it wasn't worth the time. Well, now, when you've got hundreds of thousands or millions of servers, issues before that weren't worth the time to bother with now become very, very, very important. So with Facebook, now that they have all these data centers up and running, one of the issues that they are running into is power. They consume a tremendous amount of electricity, right? So in order to cool the servers, in order to power the servers, so on and so forth. If they can save even a 1% off of their electricity bill. And you may be thinking, Eli, what's 1%? Who the hell cares about 1%? What's 1% of your electricity bill for the month is like $1.50 or $2, right? Well, 1% for somebody like Facebook, maybe $100,000, multiples of $100,000, maybe $500,000 for all the electricity they use. So if they can make things, their server, their data center facilities, a little bit more efficient, that's millions upon millions upon millions of dollars that they can save. Now, where the Open Compute project comes in is, so before, like I say, and you've got, whenever you're thinking about technology, you've got to be thinking about this timeline. That's why I always try to position things in time. 2013, 2005, 1995. I try to position things in time for you so you guys understand what's going on. So all the way up until 2011, basically until right around now, 2013. You've had these web companies, and then you've had the manufacturers, you've had the vendors. Well, every company is going to build based on what they think is best for their profit margin. So previously, the Dells, the HPs, the Lenovos of the world, they've been building all of these servers, but when they build servers, they want certain things to go out the door. It's not simply about selling the product, but it's things like branding. So if you buy a Dell server, it's going to have a little Dell symbol on it. If you're going to buy a Lenovo server, it's going to have a little Lenovo symbol on it, right? Because when the vendor sells, when the manufacturer sells that product, not only do they want to sell the product, but they also want to have a little branding, a little marketing. So when you walk into a facility, you can go, wow, you use all Lenovo servers. I know that you're a good company. Well, one of the issues with these data centers, as they're growing, as they're consuming more and more power, they've gotten engineers to go in and try to figure out how to save power, right? Well, one of the issues they found, and this is really kind of interesting, those stupid little logos that I was just talking about, that Dell or that HP or whatever, just that stupid little plastic piece they put on the front grill of a server, apparently that actually, in fact, does make a difference in airflow. Simply putting that stupid little plastic Lenovo or HP or Dell on the front of a server reduces the airflow just a tiny, tiny, tiny amount. But when you multiply that tiny, tiny, tiny amount times hundreds of thousands of servers, you end up, if you rip that stupid little plastic bit off, actually saving a lot of money at the end of the day. Well, as we've been going along in this whole continuum of technology, right? Now, before about 2011, before the whole social networking revolution, all these manufacturers who produce servers, essentially, they produced the server that they wanted to produce, and the data centers bought whatever server they thought was best. So HP had their server, Dell had their server, Lenovo had their server. There were some differences, but there were a lot of things that were the same, like stupid little plastic branding, right? Well, the manufacturers were the ones manufacturing the equipment. The social networking sites didn't manufacture the equipment, so they simply had to buy essentially whatever the manufacturers sold them. So the manufacturers had their product line, and then the consumer, the social networking, the data centers, had to buy one of those products. That's the economy. That's capitalism. One interesting thing's been happening is that with these data centers, these companies are now buying so many servers that they are actually becoming markets unto themselves. So instead of Facebook having to go to Dell and beg for Dell to build a certain type of server, Facebook is literally buying so many servers, they can go out and contract to have whatever server it is they want built. We want a 1U server with this built, and we are going to buy 200,000 of them. So the dynamics here are changing. Before, it was the manufacturer essentially stated what could be bought, and then the consumer had to buy whatever it was. Now, Facebook, Google, Twitter, they are buying so many servers, they can actually demand and contract out the production of servers for themselves. Because again, for a manufacturer, hey, selling 200,000 servers to Facebook, that sounds like a pretty good deal, right? So that's the dynamic that's been going on. So now we have to be thinking about Facebook. We have to be thinking about the world as it is now changing. So how does Facebook make its money? How does Twitter make its money? How does Google make its money? They don't make their money off of hardware. They don't give a darn about hardware. They don't give a damn about hardware, right? What do they care about? They care about updates and feeds and all that kind of stuff, and about saving money. So one of the issues that Facebook ran into when they were building these data centers and now building their new servers and building all this stuff is that they were kind of stuck because they were doing what they thought was best, but they knew that it may not actually be the best, and they didn't really know where to go for help. Because, if you start contracting out to have your servers built, is Dell going to help you? Is Lenovo going to help you? Are these vendors going to help you so that you can buy products from other people? Probably not. So they came up with this idea for the Open Compute Project. The idea, they are not in the hardware manufacturing business, but they need hardware manufactured, and they need the best possible hardware manufactured. So what they decided to do, and this started, as I understand, with the data centers, is they created the designs for the data center, and then they just gave it away for free. They made it open source so that anybody could use that information. The reason being, just like with software, if they design a data center, and then they make that data center the diagrams and all of that open source, then another person, let's say Google, may take those diagrams and they may see that there's something better. So they tweak a few things to those diagrams and they make an even better data center. Well, the next time Facebook needs to build a data center, they don't go to the architectural schematics that they have from their last one. They then go to Google and they say, oh, you used our designs, plus you added some stuff. We like that. Plus, it's now a year later, and now we see the benefits of some other things, so we'll add those together, and so we'll make it even better. So the idea is that we come up with this collaborative environment in order to design all of these hardware things. So when we're talking about the Open Compute Project, the big thing to understand, this is about data center environments. So we're talking about data centers themselves. How do you cool a data center more efficiently? How do you set up the HVAC systems? How do you set up the electricity? So on and so forth. We're talking about the servers themselves, the cases for the servers, the power supplies for the servers, the connections to the networks for the servers. We're talking about things like storage. So again, when you're dealing with somebody like Facebook, when they're storing terabytes upon terabytes upon terabytes upon petabytes of information, how do you store all of that data? Because at the end of the day, it's got to be put on a hard drive, and then you've got to link a bazillion hard drives together to create some kind of data storage device. So they have storage diagrams and such. Like they have one, it's like this 48 slot 4U hard drive case, essentially. So you can slot in like 48 different hard drives. It has really efficient cooling so that you can use that as the storage. They have something called virtual I/O, so the input-output interface. Because again, how do you communicate with the devices, with the hardware as fast as possible? And then overall hardware management. Again, when you're thinking about it, when you're thinking about servers, you're probably thinking about 5 servers or 10 servers. But when we're talking about how do you deal with 100,000 servers, when you have 100,000 servers, 3 are going to die every day, probably. So how do you figure out which 3 actually died? How do you figure out how you can do preventive maintenance and maybe get it down to 2 die every day? So on and so forth. So the Open Compute Project is an open source hardware project that's designed, that the entire concept is based around the data center environment. Let's go over to the computer just for a second so I can show you their little website and show you some of the good stuff that they have on it. So if you go, and it's opencompute.org if you want to get any more information, and here's where you can see what we're talking about here. So we have the server information, the storage, the data center, the virtual I/O, hardware management, and then certification. So if we go over to like server, It'll just give us some information, like it's talking about the AMD, the ARM, high ability, Intel, so on and so forth. But if you're interested in more information on the Open Compute project, this is where you can go get it. Now with this then, so you're thinking about, well, Eli, okay, so we're talking about the data center environment, but what are the things that are going to come down to me and may be very useful in the future? So we're talking about the data centers, we're talking about airflow, we're talking about cooling, we're talking about electricity consumption. Well, one of the things that has come up with all the geeks and the engineers talking is one of the biggest pains in the butts that they run into is CPU sockets. So they talk about it, and in a data center environment, when you put in a server, the RAM on that server is going to last a long time. The hard drive on the server is going to last a pretty long time. The motherboard is going to last a long time. The one thing that actually does get upgraded in these data centers quite frequently, they would like to actually upgrade it more, is the CPU, central processing unit. You know, Intel, ARM, AMD, i7, Optiplex, whatever. That is what they would actually be able to like to upgrade. And one of the issues that they run into right now, right, is if they have an Intel motherboard, well, then they have to upgrade to Intel. If they have an AMD motherboard, they have to upgrade to AMD. And what they're saying is, we don't care about Intel and AMD. We don't want to worry about this. We want a CPU. We want to pull out the old CPU. We want to plug in the new CPU, and then we want to be done with it. You know, the finance wonks and the computer scientists can decide whether we buy this AMD or that Intel. We don't care about that. When I'm a sysadmin, when I'm out there dealing with the systems, I just want to be able to open the case, swap out the CPU, and be done with it. Well, one of the things that's come out of this Open Compute project is the ability to actually be able to do that. So Intel and AMD and the motherboard manufacturers are all working together so that there will be one socket type, at least for this data center environment. So if you have an Intel CPU and you want to switch it over to an AMD, you'd literally just be able to pull it out, plug the other one in, turn the server on, and away you go. So these are some of the really cool things that are coming out of this Open Compute project. Now for you, why this could be important, because most of you guys, frankly, are not going to be working in the Facebook data centers, the Google data centers, is of course you should know about this, right? You should know what's going on because it's a good thing to know about. The other reason that you should know about this is in your own little data centers, you know, with your two racks, right? Because there's a lot of manufacturers that are now producing per the specifications of what's going on with the Open Compute project. So you can still buy Dell, and you can still buy HP, and you can still buy Lenovo, but there are a lot of now white box manufacturers that are producing server equipment based on the Open Compute specifications. Now think about it. You're not Facebook, you're not Twitter. Saving 1% on the electricity bill is not going to save you hundreds of thousands of dollars a year. But you know, depending upon your little server room, it might actually save you like $1,000 a year. So something that you should be thinking about is if you have your own little data center, it might be one rack with 10 servers on it. But as you swap those out, you should be thinking about looking for equipment based off the Open Compute project, because it will be more efficient. And one of the nice parts is it will be easier to be able to deal with, to be able to repair. Again, one of the issues when you buy from a lot of these vendors is I don't know who the hell designs some of their equipment, just because trying to get into it and mess with anything can be an awful nightmare. Well, with the Open Compute project, again, not only is it energy consumption, not only is it cooling, not only is it CPU, but it's the ability to quickly get in, be able to do whatever it is you need to do, and get out and get the server back up and running. So that's the other thing. Again, even if your data center is all of one rack and 5 or 10 servers, starting to, when you do your refresh cycle, buying Open Compute project standard equipment may be a very good way for you to go. Again, you know, the business saving $1,000 over a year, I mean, $1,000 is in fact $1,000. The other reason that this is very important, again for you desktop support or you computer repair people, I do hope you guys are all getting out of simply being computer repair. But for any of you guys that are computer repair, is that the idea, the motivation for the Open Compute project is gaining steam. I remember when I first heard of open source hardware, again 5 or 6 or 7 years ago, and it was some really esoteric crap. I mean, basically it started off in the robotics world, right? So if you didn't do robotics, you probably weren't dealing with open source hardware. Now it's coming in to data centers and server rooms. What I would say is most likely going to be coming down the pike is that it's going to start coming to the PCs and computer realms, and it's something that you should be thinking about. Again, all of us, we go out to buy a desktop, we go out to buy a computer, we buy an Asus, we buy a Dell, we buy a Lenovo, but as things like electricity prices continue to go up, bosses, C-level executives, they don't want to pay those energy bills, and for most of us, PCs have just become, we don't think about it anymore. Whether you buy a Dell or an HP or a Lenovo, you just you take it, you put it under your desk. It's no longer a badge of honor that you own a special type of computer. It's just the computer that you have and you use it. So if this whole open source hardware initiative keeps moving into the PC realm, what I would say is this is something that you should look out for to see what desktop systems are being designed off of these open standards, because again, they will be more efficient, they will be easier to use, so on and so forth. So some of those things that you should be thinking about. So this was Open Compute Project Introduction. Again, this was created by Facebook in about April 2011. This entire project is gaining steam. It's for big data centers, but it's something that you guys should be thinking about for your little data center. Again, even if you've only got one server rack, there's all kinds of cool stuff that you should take a look at with this. And if nothing else, because I know I've been hearing about the Open Compute Project for a while now, if absolutely nothing else, you should learn a little bit about this so that when you go to the equivalent of the geek cocktail party, you know what the hell people are talking about. A lot of people are talking about the Open Compute Project, and again, if you don't understand quite what's going on, you will sound dumb at that cocktail party. So go, just take a look at it. There's all kinds of reasons. It's really, really cool, even if you're not using it in your own environment. Again, one of the reasons that I would say is if you see the movement of the open source hardware initiative, you can see it's gone from esoteric niche to big enterprise corporate to a little smaller corporate, and you can tell that it's going to be coming down to us consumers pretty soon. So, as you know, I am Eli the Computer Guy. I enjoy teaching this class, and I look forward to seeing you at the next one.